All right, so hello and welcome. Here we are, another question. Oh, did I save the right title? Oh no, I didn't save it. Oh no. Never changed the title. Oh no, it should be. Yeah, it's good. We got it. Okay, we're fine. I was gonna say I changed the title.
Hello.
Oh no. Yep. Okay, so got the chat out here. Got the audio, video, everything looks like it's good. Let me continue. So we'll go here. And we'll go to delete nodes and return forest, close this. I think we're good to go. All right, next question. So just moving right along. Delete nodes and return forest. Given the root of a binary tree, each node in the tree has a distinct value. After deleting all nodes with a value in to delete, we are left with a forest, a disjoint union of trees. Return the roots of the trees in the remaining forest. You may return the result in any order. Okay, so what are they asking here? 1, 2, 3, 4, 5, 6, 7 to delete 3 and 5. So delete 3, delete 5, and now we have 1, 2, 3, 4, 6, and 7. Oh, I see. That's interesting. Okay. Number of nodes in the given tree is at most 1,000. Each node has a distinct value between 1 and 1,000. To delete, length is less than or equal to 1,000. To delete contains distinct values between 1 and 1,000. Okay, this is not too bad. Acceptance rate to 70%. So this has a pretty high submission rate. So I think what you can do is just put the node pointers into an array, right? And then access those pointers, and basically just going to have an array of, the result pointers after the deletion. So let's do tree node array of n. Actually, it could be bound. So yeah, this question is not too bad at all. And we're going to say fill with null pointers. And we're going to say first just run a DFS through the tree to assign those. Actually, this should be an array. Yeah. Because you can't use a dynamically sized array in a lambda expression like this. In a lambda expression. This is, I think, fairly straightforward. I'll explain in a moment what I'm going to look to do. Node DFS. This is going to be from root. And we're going to say f of node left and node right. Okay, so the way this is going to work is I'm going to say get the value. So I think these are unique, they said, right? Yeah, it's unique. So this, oh no, just to delete is unique. Oh, each node is unique. Yeah. So this is not, this is kind of made a lot easier because these are unique. So it's going to be const, so if not node, then return. Otherwise, we're going to say array of node value equals node, right? So now we assign at each value the pointer associated with it, right? So now when we run through the delete routine, to delete, so we'll say x into delete, we can do the following. We can say the array of x is the pointer to that node, right? That was kind of the point of all of that, which is what I want to use. Now, my thinking is something like the following. The left child and the right child, when you delete a node, the root node, the left child and the right child, they're not null pointers. Those should become parents of subtrees. Those nodes themselves can be deleted, in which case they would not be parents of subtrees anymore. So I think the easiest thing to do would just have a Boolean and just call it is parent, or is new root. Let's phrase it that way. Yeah, that's better. And fill that initially with false. So everything is not a new root except the root node itself. That should be true. That's the only one that should be true. And we always have at least number of nodes is at most 1,000. Could have 0 nodes. Could have 0 nodes. So if it's I think if that's an edge case, right? Where if the root is, if there's no tree, then the output should be vector of tree node should be just an empty vector. Let me test that quickly. Let me just test if that's that input, if that case is a possibility. See what this does. How are we doing on time? 6 minutes in? Okay. Yes, so that's possible. Yeah, okay. It's a good thing I checked that. That's an edge case, and it's allowed. So we set is new root to true. Now we say at to delete, we're gonna say array of x. So it's gonna be is new root of x is false. It was true before. I might want to just say just thinking delete the nodes. They want me to actually perform the deletions too. Turn the result in any order. I think I also want the parent too. I mean, there are a few ways we could do this. Trying to think. Geez. There are some things to consider here. Oh boy. Uh-oh. Think about things related to memory too. In order to delete a node, you don't want to have dangling references, so you need to take the parent node and set its reference to a null pointer. You know, it might be better to actually perform the deletion like kind of recursively, I suppose. That's confusing. I really think about this now. I'm wondering if I just want to perform the deletion like as I'm looping through, recursing through. I could do it that way also. That also works. Kind of wanted to do it this way though, where I just delete the nodes directly, like kind of gather all the nodes and then delete them directly. Problem with this though is that you need to know the node's parent, which is kind of annoying. Yeah, it's probably easier to just do it in one shot. Just DFS and then return the root. No, it's confusing. Awkward. Okay, it's a little awkward how I'm trying to do this. All right, I think I'll just never mind. We'll do it. I could try to do it the way that I was gonna do it before. Also parent, I think, is the way to go as well. Yeah. So if there's the node, then I've also got parent, which is initially just going to be a null pointer. I don't know about this. It's kind of a little bit awkward. So we're going to say parent of, say, P. Parent of node val so that's the node and its parent is P. And then we call node and node. Yeah, I mean, that's fine. So now we have the array. We get the tree node from its value and then the parent as well from that same value. Now, in order to delete, I think, excuse me, this would be a little bit simpler, but it's not that simple. So what I'm going to want to do is mark that node as deleted, and add the two children to, let's say, possible root. So possible root is initially false, not new root, but possible root. And when it's deleted, it gets set to false. Yeah, what's confusing about this is the confusion is that when I delete a node, a root node, when I delete a node, it's the root of a subtree, and it's two children left and right. Both of those should become possible roots. However, I could end up deleting those later, but if I deleted them already, so there's possible root, and then there's also deleted root, which is probably what I want, actually. Some of these are not possible roots. Yeah, I think probably it's easier to just do it this way. I have two of these, deleted root and possible root. So if they've been deleted, they can't be possible roots, even though they might be marked as possible roots. That's the confusing part. So possible root is going to be, the root value is true. Now for everything that can be deleted, I'm going to say possible root once it's been deleted is false, and deleted root is also true. And for the children, so if, let's find tree node t or n or node is going to be array of x, and also let's assume the values to delete are in the tree. So if node exists, then we say if node left, do one thing. If node right, we do another thing. They exist. So if the left node exists, then we're going to say constant left val is going to be node left value, right value. A little bit of duplicated code here, but that's okay. Okay, the node on the left side exists, and I can get the value, and then I could say possible root is true of left value, and it's not deleted. The same thing on the other side. Yeah, Yes, so those become possible roots. They're not deleted yet, but they could be roots. Okay. And once a root is deleted, then I'm also going to say node left is null pointer, node right is null pointer, and I'm going to delete the node altogether, right? And the parent node, let's say tree node parent, P is parent of X. If P exists, then let me say if P left is equal to if the address of P left is the same address as node, right? Then we're going to say P left equals null pointer. And if P right is equal to node, then P right is null pointer. Okay. Oh boy. Boy, oh boy, oh boy. Yeah, a little bit complicated, quite frankly. So we take the node, we have the left and the right, become null pointers because it's going to be deleted, but also the parent node, if it exists, either the left side or the right side also needs to be removed, right? Made null pointer, and then we delete the node. Yeah, that's a bit confusing, I realize. It's deleted, it's a possible root, it's false. Children become possible roots, null pointer gets set, and then we delete the node. Yeah, it's actually pretty involved. And after all of that, we could say for each, int I is 0, I is less than array of, or bound, let's say. We can say if array of I is not the null pointer. Also, I think we want to set array of X to the null pointer at the end of this too. Delete node, by the way, set that to the null pointer, so it's deleted and not a possible root and all those things. And possible root of, so if array of I exists, and possible root of I, and deleted root of I and not deleted, then have this result. Just result.reserve bound. Keep that simple. And it's going to be array of I think, is what gets pushed back. So yeah, that's confusing, I realize. That is confusing. It's a little more involved than I was expecting. Okay, it's correct so far. There's a high chance this is not correct in all cases. Yeah, 1 to 1,000 distinct nodes. Let me try a few unusual cases. Like there's one like that, and then maybe 1, 3, and maybe 1, 3, 4, 5, and maybe 3, 4, 5, and maybe 3, 4, 5, 6, 7, 8. And we're going to delete like 3 and 7 and things of this nature. Let's see about these things. Run into any problems doing this? Okay, it's right in all those cases. Okay, might be correct. I don't know. Maybe. I'm gonna go for it. It could be wrong. Significant chance it's wrong. Yeah, okay. It's typical. I probably needed to do more tests, quite frankly. I needed to use more null. Null values, because you run into problems with null values. Yeah, I forgot to do that. I kind of like thought about it for a moment and then just forgot. Just didn't do it. Either like, well, I decided not to do it. Yeah, kind of forgot to try testing with more null values. I thought I had enough if statements, but yeah, apparently there was something that I missed. So you get a runtime error. Okay. So this looks like isn't there a way to see the trees? I thought this shows the mystery. I guess it's not working. Oh, that's weird. Okay, not great, but let's see. So we have 1, 2. I don't remember when you press this button. It's supposed to show 1, 2, null, 4, 3, and 2, 3. Let me. Okay. There's supposed to be a way to see this. It's generally good. Oh, console. Okay. Yeah, there's generally a way to see the trees, right? To see the binary trees. Oh no. Anyway, all right, whatever has an explanation, but that's not really what I wanted. Whoa, oh no, I had the wrong. Okay, my mistake. I think 1, 2, null, 4, 3, something like that, or 3, 4. It was something along those lines. Yeah, it had a little button here. You can see the tree, which was very helpful, but I don't think it's working. It's disappointing. Yeah, because if you could see the tree, so I think it's 1, 2, right side is empty, 3 and 4. It must be 3 is connected to 2. So we have 1, 2, empty, 3, 4, right? And when you delete the 3 and the 4, those are leaf nodes, both of them. And then you also delete the 2. So what happens? So these are fine. I think the parent should also be set to a null pointer as well. That could be part of the problem. I don't think so, but maybe. Okay. No. What could be wrong? So let's see if it's the DFS that causes problems. Shouldn't be the DFS. Not sure exactly what's causing the issue. Not sure exactly what's causing the issue. Okay. Not the DFS. Okay. Oops. It could be, let me get rid of the test cases too. It could be this part that's causing issues. I don't think so. See if we get that far. Could also just be this here. Okay. Oh boy. Yeah, I don't see it. This is like too complicated. One of the reasons I don't like to just attempt. So it doesn't get down to here to I, so it stops on 3. So when I delete 3, it causes a problem. The test case is 1, 2, 3, 4. So something about 3 is causing a problem. 3 possible root is false and deleted root is true. This should be fine because x is bounded by 1001. It's from 1 to tree node array of x should give me that. It's fine. If the node, which should be true, node left is false, node right is false, so those should just skip altogether. Node left becomes no pointer, node right becomes node right becomes no pointer. P's parent is a null pointer, right? Right, because we deleted 2 already. It should be null. Should be a problem. Delete it. That's if the node exists. What is the issue? Why is it? I don't understand. Missing something important here, I'm sure. Is it inside this block? Yeah, trees can be really tricky sometimes. Shoot. So 2, 2, 3. Okay, so 2 is fine. 3 doesn't get all the way through. Which part of this is causing issues? I don't know, understand. That's pretty disappointing, but happens. Especially when you have so many conditions here, it's hard to follow. Oh, that's what it is. Oh, duh. Oh my goodness, that's pretty obvious actually. Of course. Oh my goodness, that's actually pretty easy to see. I didn't even realize that. Shoot, I thought that everything I did was covered by the conditionals, but I was wrong. I missed one. That's hard, man. I don't know. I don't know what to say about that. It's hard, and sometimes just the way the test cases are set up. Sometimes it's kind of hard to like generate the test cases you need. It's disappointing. Yeah, that's the issue. So if node is left, then you can set it to a null pointer. But if it's already a null pointer, then setting it down here is going to cause problems. Yeah, that makes sense. That makes sense. That makes sense. Okay. Deep breath. That's disappointing. Definitely should. Oh no! Oh, there's more to it than that. Okay, never mind. That wasn't even the whole thing. All right. Of course. Of course, there's more to it than that. Oh, all right. Jeez, really? Oh my goodness. What? No, come on. Say it ain't so. Say it ain't so. No. Okay, I still don't know what's wrong. You gotta be kidding me. That's difficult. That is difficult. Oh, okay, this might be a rough one. I don't think I should have gotten this wrong. Well, whatever, that just happens. Sometimes you get it wrong. Sometimes you make a mistake, don't realize it. Yeah, when it gets really complicated with a lot of if statements, it's very easy to make a mistake. 500, 600, 500. I should probably also put in. So yeah, there's some error in here. Really? Okay. Which one is causing issues? How could this be? I mean, I don't know. What am I missing here? I'm missing something important. Whatever it is, I'm not seeing it. 500 to 600, I think this goes all the way through, and then 500 to 540. 500 to 540, really? So how could this be a problem? Because if P exists, it's not a null pointer. So is P left the issue? I don't think that's it. That can't be the problem. How could that be a problem? Is that already deleted? Is that what it is? Maybe this needs to be a null pointer? That's confusing. I mean, maybe this is what I need. I mean, that kind of implied by that, but what's going on? I don't know. I don't know what I'm looking at here. So 500 to 600 is the first iteration, 520, 540, 560. And then boom, doesn't get to 47579. Does it get to this one? Just go 570 there. What is going on? This is bizarre. It crashes right here. What? Huh? I think I also should set this to the null pointer. I don't know if that matters, but might as well. What is going on? It's a heap after free? Heap use after free? What? Maybe that's the issue? No. Is that a dangling pointer of some kind? Is that what that is? What is going on? So confused. It's got to be some kind of memory related thing that I'm doing wrong. Of course, of course. Wow. Gee. Well, this is unfortunate, huh? Oh, man. Okay. How could this be? How could this be? So we delete. Oh, no. Oh, no. 500 to 600. So we deleted 2, right? So 1, left child is 2. We delete 2. There's no right child. Then we're operating on 3 and 4 after 2's been deleted. So there should be no parent for 3 and 4, right? Maybe that's what it is the parent P, since it's been deleted. Oh, I think that's what it is. both of this is so confusing. So I was saying, like, maybe I should just do it all in the DFS, because it's so much more complicated doing it this way. This is messy. Oh, what a mess. Yeah, I think doing it doing it all in one pass is probably the best way to do it. It's a good question. Really, that makes you think about all the memory-related things. Yeah, using less. I think I see what the problem is. So the parent value needs to be updated properly. When you delete the node, both children parent values need to be updated. That's the issue. Yeah. And we're going to say parent left value equals null pointer. That's what it is. I think that's the issue. I think that's what's going wrong here. That's pretty easy thing to miss too. Yeah, pretty subtle thing. Jeez. Yeah, it's too much. This is not the best way to do this. There's too many problems with this. Also, quite a difficult bug to debug as well. Like, it's exceedingly difficult to realize that. Yeah, it's just it's confusing. It's a confusing mess. All right, let's go back to. I'm gonna try again. I'm afraid to submit this again. Well, this is why you practice, right? This is the point of practice. There we go. Got it. Okay. It's slow. Got it wrong the first time. We'll submit it a few more times. I don't think that's the best way to do that. That's a little bit too complicated. Too complicated and kind of slow. It's very easy to make mistakes like the one you just saw. That was pretty unfortunate, pretty sad. And yeah, the runtime's pretty slow anyway. I think a single pass is the way to go for this one. What you would do, probably still have possible roots, right? Deleted roots and possible roots. I think that's fine. Make these vectors of booleans. Oh boy. Okay. And then not have this array and these parents and all of that. Just put this into a just array delete. All right. Try it this way now. And do it all like up front. Yeah, that was messy. I mean, that is just messy. Ugh, gross. It's one way of doing it. I wouldn't recommend that. I don't think that's a good way of doing it. It's too messy, too complicated, too slow. Takes too long to code. All of that. Yeah. Not really worth it. Okay, so this kind of uses a lot of memory the way I'm doing it, but I think this is okay. Actually, yeah, let's do that. Okay, I want to do this in one DFS pass. I want to do it like that. Try to do it like that. And return the result. So the idea is going to be I don't know. I don't know now. Gee. Okay. So I want all of the nodes to be collected in result that haven't been deleted, right? Have not been deleted. Okay. So let's get the value of the node. Let's say array delete value should delete, or just remove, we'll say. So if remove, then now in both cases, we're going to recurse the left side and the right side. If we remove, then we're going to say left is the null pointer, right is a null pointer, and the parent. We do want the parent. Parent, again, if it's the left side or right side. Okay. Set all of the pointers and then delete node and then set node to a null pointer. Okay, do all the deletions afterwards, I think. Post order. And we're gonna say move. Okay. So if not, delete array delete of node left. So if node left, and not array delete node left value. Then we can say result.pushback node left. The same thing on the right side. This is pretty complicated. Does that work? So that's kind of involved. A little bit better than what I was doing before, though, I think. Yeah, a little bit more concise. Not as much to think about here, to worry about. So if it's not going to be deleted, then we can add that. That's going to be a parent, the children. If it exists and it's not going to be deleted. Yeah. I guess we could do this after the recursion. I think that's fine. Does that matter? I don't know. Is that all I need to do? Is that all I need to do? I don't know if I need possible root or deleted root if I do it that way. Just array delete is all I need. I don't know. That seems a lot simpler. If that's the right way to do it. That's one way of doing it. There. Part of me thinks maybe it is that simple. Wrong. Okay. All right, deleted 1, 2, null 4. For some reason I deleted that. Oh, I see. Yeah, well. And that one too, right? Is it that simple? I don't know. Huh. Part of me thinks maybe. Is it? Maybe that was all I need to do was just check whether or not the left node and right node are. Go for it. This could be wrong. Definitely could be wrong. Oh. No. It's too much. Too many test cases to go through. So many test cases to go through. Runtime error. All right. So this was this test case. 1, 2, 3, null, 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 4. Should be 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then 2, 1. 1, 2, 3, and 4. And somehow I get a runtime error here, of course. Oh, it tells me which one. Okay. With a member access with a null pointer type tree node. Of course. Parent could already be deleted. Didn't think about that. Probably should have tested that. So many like what do you call that? So many. just keep submitting it. So many mistakes you can make here. Yeah, it's brutal. That's a lot faster. Much better. Ouch. Ouch. Oof. Yeah, I mean, yeah, the parent could be a null pointer. It's true. This could be, by the time you modify this, parent could be deleted. That's awkward, huh? That's awkward. I did not consider that. How do you even remember that? How do you know that? I don't know. It's pretty awkward. It's pretty awkward, I have to say. You know what? I had a tree node previously that had a deletion operator that was I deleted recursively, delete a whole subtree when I remove a node, but I could see why. Well, no, that's fine. If you just set the nodes, if you just set the children to null pointers before you delete the node, I think it's fine. Yeah, you can still have you should probably have a recursive delete operator. Gee, I don't know what to say about this. I mean, I missed this one too, with this parent being deleted. I mean, it's pretty complicated, quite frankly. It's pretty easy to make a mistake here. I don't know why this has a very high submission rate and acceptance rate. Both of those things are pretty high, right? Yeah, both are very, very high, actually. I feel like also people like this question a lot. It is a good question. Definitely caused me a lot of trouble. How many submissions do I have? 1, 2, 3, 4. Just submitted a bunch. That's faster, this approach. What I had before, it seems. I don't know. Ouch. Ouch. Well, this is why you practice, right? This is why you practice. That's why I practice. Yeah, I mean, I don't need this, by the way. This could just be array delete. Oh, that's a lot faster. Wow, 100%. Fastest solution on the site. There you go. That made it a lot faster, huh? Whoa. There you go. Beautiful. That's what I like to see. Oh, that's fantastic. Nice. Nice. Doesn't always go that fast, but sometimes it does. Sweet. Yeah, I don't know what to say. Gee. Not always that fast. That was just randomly branch predicted very well, I think. I got a bunch of, I got twice I got this wrong. The first approach that I tried wasn't great. And then the second approach that I tried was, the first approach that I tried wasn't great. Really kind of complicated, and I ran into a runtime error because I missed one of the cases. And then the second time was a lot better in terms of complexity, a little bit faster as well. One pass through, I suppose, and then but I also missed another case, another edge case that I wasn't paying attention to. I guess it's not much faster, a little bit faster, but not much. It's about the same. About the same speed, I think, as the other solution. I don't know. Yeah, not much faster than the other solution. They're about the same. So how could I avoid like missing those edge cases again in the future? Well, I think part of it was that, and it's kind of it was the same thing twice. It was you could end up deleting a parent node. Yeah, I end up deleting one of your parent nodes while you're operating on the child node, in which case you run into trouble in this line of code. That's exactly, I think it was both times I did that. It just didn't occur to me. So you have to watch for the children, right? You're gonna set the both. Yeah, there's like a significant focus on the children being added as new roots. Excuse me, which they will be as long as they will be as long as the. Yeah, this is a tricky one, man. This is pretty. There's a few things I could say about this. This is definitely good for like practicing memory management, I suppose. And yeah, practicing with trees. It's a good question. It's good. Yeah, well, this is why you practice, right? Why I practice. So one of the issues here is the children. If you're not going to delete them, once you have a node that you're going to delete, there's three other nodes that get affected, right? There's the parent and the two children, potentially three other nodes, and the two children are going to become root nodes of subtrees so long as they're not also going to be deleted. So that's what this check is here, right? If they exist and they're not going to be deleted. And you've got to look at the parent if it exists as well, and check and update its child, right? Because I've now deleted this node, and we know there's some cases it doesn't exist because I'm doing it right here in the root node. If I delete the root node at all, I would immediately see that I have to check if that parent exists or not. Yeah. And a good way, excuse me. I think a good way to perform these deletions is a post order, because if you try to delete the node and then recurse on the children, I mean, you could do it a pre-order as well. It's just, yeah, you could do a pre-order. Let's try to do a pre-order actually. It's not const. How do you think about that? Yeah, that's fine. That's interesting. We do it this way too. Pre-order. I kind of would prefer to do a pre-order. Post-order might be. Does it still work? I think it still works. Yeah. Might be slower. 1, 2, 3, 4, 5. Yeah, pre-order is quite a bit slower. Post-order is faster. 1, 2, 3, 4, 5, and there's I can explain why. I think I know why. No, still relatively fast. I think the reason is how much memory is on the stack for the recursion. Could eliminate all of these, I think, if you do post order. I think having less memory on the stack is better, generally. I could be wrong about that. Okay. Yeah. Yeah, because if I do post order, then I haven't deleted the node yet. Whereas pre-order, I need to save some values because I deleted the node. Post order is fine too. It looks like as long as I let me keep submitting to see. As long as I pre-order, post order, as long as I, yeah, they're kind of random. The speed's kind of, it depends on the branch prediction, it seems, and some other factors, I suppose. With the tree related questions with the pointers and whatnot, it's like kind of random how fast it's going to be. As you saw before, I did get the 100%, but it was kind of random that I got there. This is more important. It seems to be paying attention to all the different cases, the parent and the children, and not dereferencing null pointers and not dereferencing things that have already been freed. Excuse me. That seems to be the problem. Thing to focus on. Yeah, I don't know. I don't know what to say here. It seems kind of obvious now, some of these things, but at the time, I was going quickly. Didn't notice. Even if I wasn't going that quickly, I still didn't notice. Yeah, it was the same issue twice, actually, is that I had deleted the parent node by the time I deleted the parent node by the time that I got there. I needed to not try to interesting. Okay, that's probably enough. That's probably enough for this question. I'm trying to think if there's anything else I should think about or cover with this before I move on. It's probably okay. Yeah, it's just a matter of practice. That's always what it is. Like, you just got to keep practicing. Otherwise, make mistakes like that. And the only way to make sure you don't make mistakes like that is to basically make them. That's really it. Make them enough where you remember not to do it in the future. You could try to come up with a strategy to like have the foresight, but it's pretty difficult generally to do that. Sometimes it works, but sometimes it's just, I don't know. Gotta have some kind of mental, have to remember it somehow, know about it beforehand, so to speak. For the most part, you only figure these things out through experience. That's really it. They have to pay attention to both the parent and the two children, and make sure they exist before you modify them. Because you could delete the parent and then the child, or the child and then the parent, depending on how you're moving through the tree. Anyway, okay, fair enough. So let me stop there. So yeah, thank you for watching. If you liked the video, give it a like and subscribe for more. I'm gonna restart and start on a new question. Hold on, am I back? Sorry about that. Oh boy. Okay. What's going on? There we go. All right. Sorry about that. My stream basically dropped for a short while there. All right, I'm gonna restart. Stop stream, start again on a new question, and keep going. Yeah, I forgot when I started, but I wanted to do like 3 hours, I think. Time is it? Well, let me do that. Let me do that. So yeah, I'll figure out like how long I want to keep going. So I'll start over now.